Okay, so good morning everyone. Today we are going to learn about 9th standard science again, and today our topic is Archimedes principle. Right. So आज के topic पे जाने से पहले I would like to introduce you to the Archimedes, the Greek scientist. Right. The speciality of this Greek scientist is that whatever the principle he found was in his bathroom, in the bathtub. Right. सोचो कि आप नहाने गए हो, in the shower you get an idea that is so brilliant कि आप अपनी streets में, society में पागल होगे ऐसे चिल्लाने लगो कि आविष्कार आविष्कार, मैंने कुछ ऐसा बनाया है जो कि दुनिया बदल देगा. Right. Similar thing happened with Archimedes. He found his own principle that was so important that it was important to design the ships. It was important to find the purity of milk, right? This principle he used to find the purity of gold in the crown of the Greek king, right? In the Greek king's crown, what was the purity of gold? He found that with the help of this principle, right? So that is how this principle was found. He found it in the bathtub. When he stepped into the bathtub, the amount of water that came out when he stepped in, from that he got an idea for this principle. And similar kind of activity we are going to do, right? So let's do it. Okay, as we have learned that when there is any substance which is immersed into a fluid like this water, the water applies some upward force into it, right? So here we are going to find out that what is the measure of that upward force, what is the magnitude of that force, right? Now we know that the upward force which water or any fluid for that matter applies on anything that is immersed into it, that is called the buoyancy, right? When anything which floats on the fluid like the water, the applied force by the water on that subject or any object, right, that force is called the buoyant force, right? So as I told you that Archimedes found the magnitude of buoyancy in the bathtub, right? How did he found that? So when he went to the bathroom, into the bathtub which was filled with water, he stepped into the bathtub, and the water that came out of it, the amount of water that came out, that was displaced, from that amount he found that what will be the magnitude of that upward force which is called the buoyant force. Similar kind of activity we are going to do now, right? See, what I have done is I have this heavy stone over here which I have suspended through a rubber band, right? And here I have made a knot so that we can see the elongation of this rubber band, right? So as you know that because this rubber band is obviously elastic, right? And when I will release it, the rubber band will be elongated, right? So when I have not put it into the water, the elongation of this rubber band, if we want to measure the elongation of this rubber band, I have used this scale, and you can see that the knot is at 6 centimeter, meaning that the rubber band is elongated till 6 centimeter, right? But let's see what happens when we put it into the water. Let's see what happens to the elongation of the rubber band. Let's see. I am going to immerse it into it, right? And we have to observe that till the whole stone does not immerse into it, what happens to the elongation of the rubber band? See, as the stone touches the fluid, the elongation of rubber band you can see over here, which is decreasing.
you can see now it is not 6, it is less than 6. And as I am putting the stone more into the water, it is decreasing, right? So elongation of the rubber band will decrease till the whole stone isn't immersed into, right? Now you can see that whole stone is immersed into the water, and now the elongation of rubber band is only 5 centimeter. Before it was 6 centimeter, but now when the stone is immersed into the water, it is now 5 centimeter. But what will happen if I immerse the stone more into the water? No change in the elongation of the rubber band, right? But let's see what happens if I remove the stone out of the water. The rubber band is now again of 6 centimeter, right? So here we can see that elongation of this rubber band was because of the weight of this stone, right? Because of whatever the weight of the stone, this rubber band was elongating, right? But when we put this stone into this water, the elongation of the rubber band was decreased, right? Meaning that the water was applying, or we can say that it was opposing the force that was of this weight, right? The force of water which was upward, which we can also say the buoyant force, was opposing this stone upward. That way, that was the reason why the rubber band, elongation of the rubber band was decreasing when we put it into the water, right? So elongation of water will keep decrease until the whole stone is immersed into the water, right? So how did Archimedes found that the magnitude of buoyancy will be? So he stated that the magnitude, or we can say that the value of the upward force, which we also call the buoyant force, will be equal to the whatever the fluid is displaced when there is any object is immersed into it. मतलब क्या हुआ कि अगर हमें फाइंड आउट करना है कि भाई इस स्टोन पे ये वाटर जो है वो बुoyant फोर्स कितना लगाएगा, उसकी वैल्यू कितनी होगी, तो हमें देखना होगा कि जब हम इस स्टोन को इमर्ज करते हैं इनटू दिस स्टोन, व्हाट इज द अमाउंट ऑफ वाटर दैट इज डिस्प्लेस्ड, राइट? मतलब कि अगर मैं इस वाटर को, इस बीकर फुल ऑफ वाटर को अप टू द ब्रिम, यहां तक पानी से भर लूं, राइट? And if I immerse this stone into the beaker, some amount of water will come out of this beaker, right? So from that, whatever the water came out of this beaker, the amount of the water that came out, that will be equal to the upward force that water applied on this stone, right? That was the Archimedes principle. With the help of that, he was able to figure out that how we will design the ships, how the lactometer, or we can say the purity of milk will be found, right? So that is why it was very.
Next topic is relative density, right? So density of any substance, we know that density of any substance is mass of unit volume, right? So unit of density, if we see, is kilogram per meter cube, right? This is the unit of density, right? So we know that every substance has its different density at given condition, right? And because the density keeps constant, it remains constant at given conditions, it becomes very important to know that density of any substance, because if it doesn't vary at given condition, that becomes the characteristic property of any substance, right? And we know that every substance has its different density at given condition. We can find out every substance density with relative density, right? So if we want to find out the density of any substance, we have to get some density as a reference. So if we want to find out the relative density of gold, we have to take reference of water, right? The density of water is 1000 kg per meter cube, right? And that of gold is 19,300 kg per meter cube, right? And if we want to find out the purity, which is also the measure of relative density, right, of gold, we are going to take a sum like this, right? So relative density is equal to, as we are going to take the relative density, right? So we are taking the density of water into the denominator, and whatever the substance which purity or relative density we are finding, that we are going to put into the numerator, which is density of gold over here. Right, so now as we have both the values over here, now there is just a simplification. The both units is same, that is why that will be cut. 2 zeros will be cut, and from this we get 19.3. right? Here there will be no unit because the same unit of this densities will be cancelled, and here we get the relative density of gold, which is 19.3, right? So that is relative density.